Once again, we are in series RL circuits, and this time we are going to look at frequency when it decreases. So our last one was frequency when it increases. This one is frequency when it decreases. So we've got down to 5 kHz. Now, from what we learned earlier in the previous video, when frequency increased, we will expect both the ohmic value of L1 and the ohmic value of L2 to decrease along with frequency. With no other variables in the formula, because 2 pi and 36 millihenries are going to stay the same for L1, we would expect the ohmic value of L1 to follow frequency. It does indeed. It goes down to 1.13 k ohms. We see the same thing in L2. It was 4.15 k, and now with that lower frequency, we see it at actually less than 1 k. It's at 690.8 ohms. So it's not really a surprise then, based on what we saw in the last video, that when we add those two together, we come up with a total inductive reactance that is lower than the original value that we had. Okay, so now we look at our impedance, and based on the previous video, we are expecting impedance to also go down. So it was 12.98 k, and now with the new numbers, it is just 7.23 k ohms. Now again, we know that impedance and current are inversely proportional, so we are expecting our total current to go up. When we look at our original number, we know it's no longer 1.54 milliamps. Now we have 20 divided by 7.23 k ohms, and we get a total current that is indeed much larger of 2.77 milliamps. Again, when we looked at our previous circuit, we talked about our expectations based on current and ohmic value changes in our circuits. So resistance we know didn't change, and based on what we know already of these types of circuits, we know that an ohmic value that doesn't change will follow total current. So we are expecting R1 to increase. And when we look at the values, we see that it has indeed increased, actually quite a bit. Now, again, from our previous videos, both in RL circuits and in just series resistive circuits and even series parallel resistive circuits, we know that where we see ohmic value increases and decreases, we expect to see our voltage drops follow our ohmic values. So we are expecting both L1 and L2 to decrease in value. So if we look at the voltage for L1, it has indeed gone down, and similarly the voltage in L2 has also gone down. Now, even though those two reactive component voltage drops have gone down, when we add them together and combine them with the much larger resistive value that we now have, we find that we still, when we're using the square root of the squared, we still get applied voltage when we are looking to combine all of our voltage together to verify total voltage. Alright, I hope this reinforced everything that you have been learning up to this point in series RL circuits. Next, we are going to look at opens in a series RL circuit.